Chapter 17, think and rank. We got two problems here. So first is ranking the boiling temperature. So recognize what part of boiling is, and I didn't do the demonstration in class, and it's not a spectacular demonstration, but it probably gets across the idea. But you have water basically in a container here, and there's air pressure pushing down on it. And this adds pressure to the water, which actually keeps it in check. So if you could remove the pressure on top of it, the water would actually boil at room temperature. And so this is why it's very difficult in mountains to cook some things in boiling water, because the water boils so much faster in the mountain, because air pressure decreases the farther up you go and inversely increases the farther down you go. And so the rank the boiling water temperatures from highest to lowest in those locations, you're basically looking at altitude. Death Valley is one of the lowest places on Earth, on the surface of the Earth, on land I should say. And so that is the farthest down, so that will have the most pressure acting on it. Sea level is next, and then Denver, Colorado, the mile highest city, is the farthest up. And so the boiling temperature will be the smallest at Denver, and then sea level, then Death Valley. Or in terms of rankings from the highest temperature to the lowest, the ranking would be ABC. For 46, you're ranking the energies needed for the phase changes. This relates very much to problem 37, which we talked about in the previous video that I just recorded. From greatest to least, ranking the energies, it takes 80 calories per gram of ice to turn it into what the textbook's calling ice water. Ice water to boiling water, you're doing liquid water from 0 degrees Celsius to 100 degrees Celsius, so it's a 100-degree change. It only takes a calorie for each gram to change it 1 degree. However, you're changing it at 100 degrees, so it takes 100 calories to change that 1 gram up to what the textbook calls boiling water. And then boiling water to steam, you're now taking the really hot water and you're putting the particles farther apart, increasing the potential energy of the particles. And so 540 calories per gram there. So the ranking is 80 grams for the ice to ice water, 80 calories ice to ice water, 100 calories ice water to boiling water, and 540 calories boiling water to steam, assuming that we have a gram of each. Excuse me. And so the ranking would be CBA. And that's it.